Hello, I'm Jeff Tranter, and in this video I will present a classic ham radio transmitter, the Heathkit DX-60B. The DX-60B is a 5-band CW Morse code and AM voice amateur radio transmitter sold by the Heathkit Company. Introduced in 1967 and on the market through 1976, it sold new for $125 US. Like most Heathkits, it was sold only as a kit, which you needed to assemble. This was the last of the DX series of Heathkit transmitters that included the DX-20, the DX-35, DX-40, and DX-100. These, in turn, were successors to the AT-1, Heathkit's first ham radio product introduced in 1953. Including the DX-60 and DX-60A models, the DX-60 series was on the market from 1960 to 1976. This is a 5-tube amateur radio transmitter supporting CW and AM modes on the classic 5 ham bands 80, 40, 20, 15, and 10 meters. It features a solid-state power supply using silicon diodes. The final amplifier is a neutralized 6146 tube and is rated at 90 watts DC input power. This corresponds to about 50 watts of RF output power on CW. It used controlled carrier amplitude modulation. It features a low-pass filter in the output to reduce the likelihood of television interference and weighs about 23 pounds. I purchased this unit in 1977 for about $100. Initially, I was rock-bound to a single frequency having only one crystal, 7.055 MHz. A Christmas gift of the matching HG10B VFO was a welcome addition that let me transmit on any frequency. Mine does not have all the original knobs. Someone replaced most of them with Heathkit HW series knobs, which are actually of better quality. The final tuning knob here is original. Let's take a look at the front panel. Starting from the left, we have the power indicator and a microphone jack, and the function switch, which selects between tuning mode, standby, and AM or CW operation. Then have a drive level control, a selector for one of 4 crystal sockets or an external VFO, drive tuning, and the selection of the 5 different bands. The meter indicator can switch between grid and plate current, and final control knobs for adjusting loading and tuning. Bottom right, we have a connector for the Morse code key and a high voltage indicator which comes on during transmit operation. On the rear panel, we have a UHF connector for the antenna coming out of the low pass filter, ground lug, input for the optional VFO, and an accessory connector that was traditionally or typically used for connecting power and other signals to an external VFO. You can also see the 4 crystal sockets, including the one 7.055 MHz crystal that I have. Taking the cover off, you can see the power transformer at the lower right, the filter capacitors, and the low pass filter at the lower left. You can see again the 4 crystal sockets, including the one with my original 70555 MHz crystal. You can see 4 of the 5 tubes. Removing the cover from the final section, we can see the final amplifier with 6146 tube is in a separate shielded metal cage. As well as providing RF shielding, this reduces the likelihood of a shock from touching the over 700 volts present in the power supply and the possibility of radio frequency burns. The final features what was called neutralization. The high grid-to-plate capacitance of the triode tubes could cause unwanted oscillation. Neutralization uses the capacitance of a wire to feed back some RF voltages in such a way as to cancel the RF voltage from the tube capacitance. Now let's briefly fire up the transmitter. I've turned on the transmitter, let it warm up, and hooked it up to a dummy load. Adjusting the transmitter for transmission on a given band involved quite a few different steps. First, need to select the crystal or VFO. In this case I have a crystal connected in position 2, and we select the 40 meter band. So we start by going to tune mode and set the meter to grid current and adjust the drive level up to about 2.5 milliamps. And we need to adjust the drive tune for a peak at the frequency of operation, and then adjust as needed for 2.5 milliamps. So now we select CW mode and start monitoring the plate current. As we move the loading up, we can increase the plate current and adjust for a minimum with the final tuning control, and continue adjusting loading up for the desired current. For full up power of 90 watts, we're looking for a plate current of 150 milliamps, which you can see someone's conveniently put the necessary parameters here using a dymo label. So we'll adjust this up, maintaining a minimum as we get towards 150 milliamps. Go back and monitor the grid current again, adjust our drive level if necessary to 2.5 milliamps, make sure the drive is still tuned. Back to plate current, again moving up to 150 milliamps, keeping a minimum. And so we're now ready to operate. As you moved within a band, you need to slightly adjust some of the controls, and switching bands, you would then need to adjust all of the controls again. Looking at an SWR meter, we can see that we're getting about 40 watts of RF output and no measurable reflected power coming back into the dummy load. This was a popular transmitter in its time, and many are still in use today. What were its main strengths? Well, it's well built, solid, and quite good looking. It's easy to service, and most parts are still obtainable today. It features a built-in power supply, where many transmitters of this era required a separate supply. And it works well with the matching HR10B receiver and HG10B VFO. Its main weaknesses were it's quite big, heavy, and takes a lot of power. It certainly isn't suitable for portable operation. There are a lot of controls to adjust, at least 4 as you saw when changing frequency or band. And it has no side tone, which is an issue when using a straight key. The AM voice mode also was mostly obsolete and replaced by a single sideband by the 1970s. I mentioned the earlier DX60 and DX60A models. The differences between them were mostly cosmetic, such as the paint and meter style used. I hope you enjoyed this short video describing this vintage equipment. My next video will cover the matching HG10B VFO and show the receiver, transmitter, and VFO setup as a complete amateur radio station.